Hi everyone, in this video I'm going to be working through grade 9 paper 2 type questions. So we're going to jump straight into it. Please let me know in the comments if you have any questions. So in the figure below, ABC is a straight line, angle B2 is 75 degrees. So they're just telling us this angle here is 75, which we can see, and B3 is 55, and they want us to work out what X is. Okay, so they usually start you off pretty easy like this. So this is just angles on a straight line. So we know angles on a straight line add up to 180 degrees. So if we add those all up, it's 180 degrees. You would obviously have a lot more space. So when you're writing it out, set it out nicely so you've got your workings and then your reasonings, because you're going to have an answer booklet for a question like this. So what we would say then is we're going to say, if I add up all these angles, so X, add 75, add 55, I'm going to get 180 degrees. Then one mark that you're definitely going to get is for putting your reason. So we said angles on a straight line add up to 180. So there we go. We've already got one mark out of two. Then all you got to do is work out X. So what I usually do is I take all the numbers across. So I would say 180, take away that 55, take away the 75 is going to give me the X. So let's work that out quick. So 180, take away 55, take away 75, we get 50. So X is 50 degrees. Okay, 6.2, in the figure below, they tell us CS is parallel to HN. So they're telling us this line at the top here is parallel to this line. And then angle EAW. So we go from E to A to W. So this angle in here is 70 degrees. Line AE, so this line is equal to that line. And then angle CAE is X, okay, which they've given us here. So they've given us that's X. So it's just a good idea to just go through, read it like that, just to get a feel for what you're actually looking at. The important thing now is whenever they tell us that two lines like this are equal, that usually means they're also telling us, they want us to know that these angles, so I always think of these as little arrows, so these angles here are also equal. Okay, so we can say those are equal. We might need that, we're going to just see. What we can see here is they say, first of all, give a reason why E2 is equal to X. Okay, so with parallel lines, remember we can always be looking for that F shape, the corresponding angles. We can be looking for the Z shape, the alternating angles, or we can be looking for the U shape, the co-interior angles. So here, if we actually check with this E2, we've actually got that Z shape. So we can see in there. So that means that X is equal to E2. Okay, which we knew because they said we have to prove that. So when we are then going to say that, our reason then is going to be, actually we've got the Z shape, so alternating angles. And the important thing is whenever you use one of these alternating corresponding co-interior angles, always list the lines that are parallel. So we're going to say, because line CS is parallel to line HN. Next up, determine the value of X. Okay, so what we have now done is we have worked out then, let's just get this a bit cleared up here. We have worked out that E2 is X, but we said that W1 is the same as E2, so that one's also X. Now they want us to work out the value of X. What I would be doing is I'm going to be looking in this triangle. Okay, we know with triangles that triangles always add up to 180 degrees. So that would be what I would be using because we have 70 degrees and we've got two x's. So we can work that out actually pretty easily. They ask this a lot, okay? So these are isosceles triangles. They love asking these. I'm just going to work it out up here. So my workings and then my reasons, I'll put on this side. So I would be saying 70 plus x is going to give me 180 degrees. My reason is because the interior, the sum of the interior angles, let's write it properly. Okay, the sum of the interior angles of a triangle add up to 180 degrees. Okay, so we could then work out, so let's take the 70 across. So I'm going to say x, let's just say 2x. So 2x is equal to 180. Take away that 70. So 2x is equal to 110. And then if I just want 1x, it's half of that. So x is half of 110, which is going to be 55 degrees. Okay, which makes sense, because then if you put that back into this diagram here, that would mean we've got 70 plus 55 plus 55, which means that triangle is going to add up to 180 degrees. Okay, 6.3, ABCD is a parallelogram. Calculate the size of angle B. Okay, I want the size of this angle in here. Okay, what we have to do first is we need to find what is this x. Okay, because actually we kind of already know something about B. So in a parallelogram, the opposite angles are equal. So these two angles are equal. So if this is 2x minus 20, that means this is also 2x minus 20. That doesn't help us too much. So we could put that down so long. We can say B is equal to 2x minus 20. Remembering you're going to set it up nicely on your page. So, and then you could say opposite angles of a parallelogram, so parm, are equal. What I would do is I'm going to work out the size of x. How I'm going to do that is I'm going to use co-interior angles, so the U shape. Okay, because we know in a parallelogram, we can see we've got these parallel lines. So I'm going to use co-interior angles, use that U shape. So I know that this angle plus this angle gives me 180. Okay, so let's work that out first to get x. So I can say x plus 50 plus 2x minus 20 is equal to 180 degrees. My reason is going to be co-interior angles. Remember, if you're going to use co-interior angles, it's a parallel line rule, so we have to give the parallel line. So we're going to say AB is parallel to, I think it's DC or CD. Okay, let's just simplify this. So on this side, if we work out all the x's, we've got 3x, and then I'm going to take all the numbers across. So I'm going to say 180 minus that 50, because the sign changes when you take it across, add the 20. Okay, then that means we've got 3x is equal to 180 take away 50 is 130, plus 20 is 150. Okay, and then we're going to take the 3 across, so we were timesing by 3, so we divide by 3 on the other side. So 150 divided by 3, or 15 divided by 3, is 50. Okay, so then I know x is 50. So what I could then do is then I could work out one of these ones. So I could say, okay, this one is 2x, so it's 2 times 50 minus 20. So 2 times 50, we have to do that first because it's timesing. So 2 times 50 is 100, take away 20 is 80. So then I know this one is also going to be 80. Okay, so for this one, the reason why it's 4 marks, if I just get a different color pen, is you get a mark for knowing that B is equal to this side. Okay, so you get a mark for knowing that. So opposite angles of a parallelogram are equal. Mark for giving a reason there. Mark for this working out, and a mark for your co-interior angles reason. Okay, let's see if we can keep going. In the figure below, AB is equal to AC. So again, it's telling us these lines are equal. And BD, so this line is equal to that line. Okay, first of all, we want to prove that ABD, so this triangle on the left, is congruent to this triangle on the right. So this, if it's 3 lines like this, it means congruent. So it means they're exactly the same triangles. Okay, so they're the same shape and the same size. So for congruency, what we need is, there's a few reasons we can use. So we could use side angle side. We could use side side angle. We could use a right angle, a hypotenuse, and a side. Or we could use 2 angles and a side. So these are reasons that we can use to prove congruency. So in this one, what I would do is I'm going to actually use Let's see. I'm going to use side, angle, side. So I'm going to show you. So in this one, both of these triangles have the same line. So they both share that line. Okay, so that means actually all of their sides are equal as well. Okay, so with congruency, again, you would have to put your reasons. So you could say here, first of all, AD, so that's, the one side of this triangle, AD is equal to AD. Then we could say, like, remember, so whenever you got these sides like this, we could say this angle here is equal to the angle there. So D1 is equal to D2. Okay, this one is given. This angle, how we know that is because opposite equal sides. So if opposite sides are equal, then opposite angles are equal. Okay, and then our third reason that we're going to use then is BD. So the line is equal to CD, and that one was just given to us. They told us that. So then we can actually use side, angle, side. So we can say, therefore, triangle ABD is congruent to triangle ACD, and our reason is side, angle, side. So you could have proven this in a lot of different ways. They did give us a lot to work with here. That would be how I would have gone about it. But if you had any other way, as long as you can prove one of these ones on the left here. Okay, so as long as you could use one of these reasons, then that would be fine. Okay, and then they want to say, hence prove that DA, okay, so this line in the middle, bisects triangle or angle BAC. Okay, that one's not too difficult. All you've got to say is because they are congruent. So we can say triangle ABD is congruent to triangle ACD. We've just proved that. So because of that, therefore, angle A1 is equal to angle A2. Okay, and if those angles are equal, then it means that it does bisect. Okay, next up, let's see. I think it's a similarity question. Yeah, we want to prove that they're similar. Okay, so first of all, show that triangle PQR, so this top triangle, show that is similar to this bottom triangle. Okay, so for similarity, there's only two reasons you can use. So if they're similar, so this one is similar like that. So for similar triangles, you can either prove that all the angles are equal, so angle, 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 or you can prove all the sides are in proportion. Okay, so you could say the one triangle is 2 times the size of the other triangle. In this one, we are going to have to use angles because we haven't given us all the sides here. But what we can do is, first of all, we can say R1 is equal to, let's just label that R3. Okay, so we can say R1 is equal to R3. And that is because vertically opposite angles are equal. Then we could say we're going to be using, we see we've got parallel lines here. So I'm going to be using alternating angles, so that Z shape. Okay, so what we could say is with the Z shape, that angle P there is equal to that angle S. Okay, so that's what I can say next. So angle P equals angle S. My reason is alternating angles are equal. Remember, you always have to give the line. So we can say PQ is parallel to ST. And then I can use alternating angles again, so just the opposite direction. So I could say then, like this, angle Q is equal to angle T. Again, alternating angles, and again, it's the same lines that are parallel. Okay, so we have proven that all the angles in the triangles, the corresponding angles are equal. So then we can say, therefore, they are similar. So therefore, triangle PQR is similar to triangle STR. Okay, and our reason is angle, angle, angle. So the corresponding angles are all equal. Okay, they want us to then use that information to calculate the length of PQ. Okay, so if they are similar triangles, that means that all the sides are in proportion. So that means this side, let's just check. So this side, this P we said was equal to that. Okay, and this one is equal to that. Okay, so it's always the opposite sides, Okay, so it's like this. Okay, so that means if we write these similarity, we can say RS, okay, so this line in this triangle over PR. So you just need to check that you're using the corresponding sides. So PR, that is going to be equal to what they want. So what do they want? They want PQ, so they want this top one. Okay, so PQ, that corresponds with this one. So ST over PQ. Okay, so you can write these similarity statements. You've just got to choose the side. So you take one side in the smaller triangle and you write it over the same side in the big triangle. And then you take another side and you write it over the side in the big triangle. We can basically fill this one in. So we can replace it. We can say, let's get a different color. RS, we know, is 6 centimeters. PR, we know, is 10. ST, we know, is 3. So all we've got to work out is PQ. Okay, how we can do this is we can actually just multiply across. That's just a quick trick for doing it. So you can say 6PQ, so 6 times PQ is equal to 3 times 10, which is 30. We want to take that 6 across. So PQ is equal to 30 divided by the 6, because if you take the word times by 6, you take it across, you do the opposite. So PQ is going to be 5 centimeters. Okay, so that is all of our geometry and all of our similarity questions. I'm going to leave it at that for now. Please feel free to let me know if you have any questions in the comments, and I will continue working through this paper in another video. Thanks for watching.